Welcome to a LinearTrack demonstration in Archean. Here we have a simple little track setup, and it's in motion being driven by a computer, which we'll look at it in the future. Go ahead and do a V and look at the information. We see it's in the position moving back and forth. Is in a default servo mode and default max speed and acceleration. So here you have a little computer running, and what I'm doing, I'm pulling out the 4 output properties: position, speed, min position, max position. There's only a single output channel, 0. That's for setting the position. And for fun, I set up a throttle to map the position of the track. Now, to do this, you must have allow IO input turned on. That is off by default. So by default, this would not work. You have to turn that on, and you can set the min-max positions here. I could through the configuration. You can't set them through code. And what I do is I remap the position of the linear track to the default min-max position. Technically, you could change the min-max to match the min-max of the linear track, and just do a one-to-one. Read the position, write it out to the throttle, but I didn't do that. All right, so to create a linear track, just pop one down. You see a positive and negative, and that's the direction that the track will run. It's arbitrary. Basically, if you run the track in the right direction, in this case, those will be positive positions. If you go the negative direction, it will be in negative positions. Positions are in meters, and the blocks are quarter meter. So now you can move the track head to any sub-block position. So if you want to set it to 0.1, that works just fine. So here I am just extending the track out. That's all you got to do is just click on it, extend it out, and you have a track. If we look at it with the V, we see that we now have a maximum position and min position. So the maximum is now 1 meter. That's those 4 blocks, and the min is negative 1.25, which is the 5 blocks on the left. And you can manually set this. This is great for sort of debugging, and if you're building something complex and you want to try out the movement, make sure it doesn't soft collide on anything. Now, to put something that moves, you just put a block object on it and build from there. And of course, we can now manually change this. And voila. Typically, when I build something complex, I move it to like an off center, just slightly off the block. So when I build on it, I know I'm building on that. It's not somewhere else on the vehicle. And if you're curious how I got the the pipe run that way, what I did, I just sort of put a that's a fluid bridge. So I put a fluid bridge, and I built some temporary blocks around, put the other fluid bridge, then ran the fluid pipe, catching them, and then I removed the sort of the extra blocks, the scaffolding blocks I had on there to do that. All right, so let's look at some code, and hit the right button here, which is not F. All right, this is demonstration code, so it's designed to be hopefully reasonably clear what I'm doing here. At the start, we define our ports attached to the computer. We have our state. I use a little simple state machine to cycle the track back and forth. You see I grab the screen of the computer and save it to a variable. That's so if I create common code that gets passed in a variable, I can continue that. Also, it means I can use the same coding pattern here as I do for a hub or a dashboard. I create some helper functions. We detect if it's idle. In this case, detected as idle if the speed is 0. Yes, comparing a floating point to 0 is not ideal, but in this case it seems to work fine, so we'll leave it as is. I create 2 more helper functions to move it to the max position, move it to the min position. That avoids hard coding any numbers. And then we drop down to our initialization. We start our state machine in idle. Then every tick, every cycle of the virtual machine we're running in, we grabbed all the positions. We grab all the data from the track unit, render it on the computer screen, and then we start running our state machine. The state machine starts in idle mode. And once we're in idle mode, we go to the right and we move it to min. Next track cycle around, we're in the track right state. We see if it's idle. If it's idle, then we change states to moving to the left. And then when we're in the left state, we also then wait and then go ahead and switch it back to the right state and go left and right, left and right, left and right. The idle state, which is only used once, that's sort of a convention. If this design was to somehow pause it and have it just wait, I can put it in the idle state and it'll just sit there. Now, obviously, in this case, it's hard coded to always go back to the right, but for that example. Typically, I would put probably the logic in the state nested if in a as separate functions, because right now I have duplicate code between the idle state transition and the left state transition. And at the bottom I have the simple code that grabs the position of the linear track and pushes it, writes it to the throttle. It does have a bug in it, which I commented there. All right, so I'm going to put this in the description of the video. And so basically I plan to use a linear track in some builds, and I wanted to create a little test platform just to make sure I understand how it works and make sure that the output values are what I expected to be. And I wanted to play around with the throttle anyway. So until next time, see ya.